This is the key to topic 24, radicals, extra 20. And on this worksheet, you have, and these are all square root equations, and you're asked to solve each of these square root equations. Now it says solve each equation, show all required work to receive all points for correct solutions. Okay, so let's look at number one. I'm going to go ahead and write number one over here. So in number one, we have the square root of x is equal to x minus 2. All right, so remember when solving a square root equation or any radical equation, you need to get the radical on one side by itself. Now, each of these equations, all equations that you see here, there's only one radical expression. So there's only one square root, one square root, one square root, and so on. Okay, so these are basically easy kinds to deal with. So in number one, the radical expression is already by itself on one side of the equation. So to get rid of the square root symbol, remember the next step is to raise both sides of the equation to a power equal to the index. Well, since we're dealing with square roots here, the index is 2. So if I want to reverse what the square root's doing, then I'm going to square both sides. So I'm going to go ahead and rewrite this over. And so you're going to say this. You're going to say, well, I'm going to go ahead and square both sides just like this, and then you do the operations that's being performed. So you simplify. So we have the square root of x squared. So remember what that means. That means that the square root and the square root do each other. So you're left with x equal, and then you FOIL this out. So when you FOIL this out, you're going to get x squared. The out and the inner, you're going to end up with minus 4x, and then the last squared is plus 4. All right, and then notice I went from a square root equation to a quadratic equation. Now you've got to solve this quadratic equation. In these problems, all of these problems, you'll be able to solve. Now they're all going to end up being going from square root equation to quadratic. And all these quadratic equations are factorable, so you don't have to use the quadratic formula. You can go ahead and factor these. They're all going to be factorable. So regardless of whether you use the quadratic formula or whether you factor, you have to make sure that 0 is on one side of the equation. So you can use a zero factor property, or you can easily determine what A, B, and C are. So I'm going to go ahead and subtract x from both sides. Notice I'm aligning my like terms. So x minus 6 is 0. So I get 0 equal x squared minus 5x, excuse me, plus 4. And then we're going to factor this. So when I factor this, I'm going to get x minus 4 times x minus 1 equals 0. And so x minus 4 equals 0, x minus 1 equals 0. And so I get x to be 4, x to be 1. Now we have to be careful. These may not be solutions. Now these are solutions to this quadratic equation, because if you substitute 4 and 1 into this quadratic equation, it works out. But the problem is that these may not be solutions to the square root equation. You have to remember, whenever you raise both sides of an equation to an even power, even 2, 4, 6, 8, 10, and so on, you may introduce extraneous roots, extraneous solutions. So you have to check for extraneous solutions. All right, so you have to check. All right, so let's check x equal 4. So to check x equal 4, you go back to the original problem, which is the square root of x equal x minus 2. Always go back to the original, because that's what you're trying to check and see if these work, because the original is what you're trying to solve. And so in place of x, I'm going to substitute 4, so I get the square root of 4. And I want to see if that's going to equal 4 minus 2. Well, the square root of 4 is 2, and 4 minus 2 is 2, and so they are equal. So x equal 4 is a solution. Now let's check x equal 1. So when I substitute x equal 1 into the original, and the original is this, I get the square root of 1 equal 1 minus 2. Well, the square root of 1 is 1. 1 minus 2 is negative 1, and those are not equal. So that means that x equal 1 is an extraneous solution. All right, so this proposed solution is extraneous, so that's not going to work. That's an extraneous solution. So remember, the extraneous solutions are basically like false solutions. So So in the process of solving this equation, you introduced an extra solution. But that solution is a solution to something. It is a solution to this, but it's not a solution to the original because obviously you see it doesn't, the right sign does not equal the left side. Okay? All right, so in your answer, you're going to say solution, and you're going to say x equal 4, and that's the only one you'll say. All right, number 2. So number 2, we have the square root of x plus 11 equal x plus 5. And again, notice that the radical equation, the radical expression rather, is by itself. So I have the square root by itself. And so to get rid of that square root symbol, since I am squaring and the index is 2, I'm going to square both sides. So I'm going to go ahead and rewrite this over. And I'm going to go ahead now square both sides. And then we do it just like you did the previous one. So the square and the square root undo each other. So you get x plus 11 equal. And when you FOIL this, x plus 5 times x plus 5, when you square that binomial, you're going to get x squared plus 10x plus 25. All right, now notice I went from a radical equation to a quadratic, and in the process I squared both sides. I raised both sides to the even power, so at some point I am going to have to check for extraneous solutions. All right, so at some point you will have to do that at the end when you get your proposed solutions. So I'm going to go ahead and subtract x from both sides, and when I do that, I'm going to get 11 equal x squared plus 9x plus 25, and then we subtract 11 from both sides, and so I get 0 equal x squared plus 9x, and then that's going to be 14. All right, and then solving this quadratic equation, I can either use the quadratic formula or I can factor. This is factorable. So I'm going to get, let's see, I'm going to get x plus 7, x plus 2. And so I get x plus 7 equals 0, x plus 2 equals 0 using the zero factor property. And so my proposed solutions to the original are negative 7 and negative 2. All right, now let's check. So I'm going to check the first one, check x equal negative 7. And so go back to the original, square root of x plus 11 equal x plus 5. And so wherever I see the variable x, I'm going to substitute negative 11. So I get the square root of negative 7 rather, plus 11 equal negative 7 plus 5. Negative 7 plus 11 is 4, so I get the square root of 4. Negative 7 plus 5 is a negative 2, but I want you to notice that 2, the square root of 4 is 2, does not equal negative 2. So x equal negative 7, this right here, is an extraneous solution. So basically what that means is that this is a solution to something in this process, and basically it's a solution to this quadratic equation, but it's not a solution to the original because the right side does not equal the left side. You can see that 2 does not equal negative 2. All right, now let's check the other one. So we're going to check x equal negative 2. And so my original problem is x squared of x plus 11 equal x plus 5. So in place of x, I'm going to substitute negative 2. So I get the square root of negative 2 plus 11 equal, and we'll see that's going to equal negative 2 plus 5. Well, the radicand, negative 2 plus 11 is 9, so the square root of 9 on the left side. On the right side, I get 3, and the square root of 9 is 3, and 3 does equal 3. So negative 2 rather, is the only solution. So your answer, you can say the solution is x equal negative 2. Right, so that's number 2. Okay, let's look at number 3. In number 3, we have the square root of x plus 6 equal x. Square root of x plus 6 equal x. So notice that again the square root symbol is already by itself. So the next step then is to go ahead and raise both sides to a power equal to this index to get rid of that square root symbol. And so when I do that, I'm going to rewrite this over. So when I do that, the square and the square root undo each other. And so I get x plus 6 equal x squared. So notice this is a quadratic equation. Also notice I raised both sides to a power. That's even. So I will have to check for extraneous solutions. All right, so notice, okay, so I got to solve this quadratic equation. So let's bring all the terms to one side, so I have 0 on the other. So I'm going to get x squared, so as we equal 0 here. So I'm going to subtract x from both sides, subtract 6 from both sides. So I'm going to get x squared minus x minus 6 equals 0. And so factoring, it is factorable. So I get x minus 3, x plus 2. And so setting each of these equal to 0, using the zero factor property, I get x to be 3, x to be negative 2. All right, so those are my proposed solution. They may both work, they may not both work, so I need to check. So go back to the original. So let's check x equals 3 first. So my original is this, so always go back to the original. All right, because we know that these two are solutions to the quadratic. Now the question is, are those proposed solutions solutions to the original? Okay, in place of x, I'll substitute 3. So I get the square root of 3 plus 6. And I want to see that's equal 3. 3 plus 6 is 9. So the question is the square root of 9 equal to 3? And the answer is yes. So x equal 3 is a solution. All right, so let's check x equal negative 2. So again, square root of x plus 6 equal x. So in place of x, substitute negative 2. So you have the square root of negative 2 plus 6. I want to see if that's equal to negative 2. Well, 2 plus 6 is 4, and the square root of 4 is 2, but 2 does not equal negative 2. So x equal negative 2, what that means is that this is an extraneous solution. It's a false solution. So this proposed solution does not work in the original. So it's a solution to this, but not this. So the answer, you're going to say the solution is going to be x equal 3. That's your solution. X equal 3. All right, number 4. Number 4, we have the square root of 15 minus 3x equal x plus 1. So again, the radical is by itself. And so I'm going to raise both sides to a power equal to the index. Since I'm taking the square root, the index is 2, I'm going to go ahead and square both sides. And when I square both sides, the square and the square root undo each other. So I get 15 minus 3x equal, and then when I square this binomial, I'm going to get x squared plus 2x plus 1. Adding 3x to both sides, I'm going to get 15 equal x squared plus 5x plus 1. Subtracting 15 from both sides, I'm going to get 0 equal x squared plus 5x minus 14. And then this is factorable. And so when I factor this, I'm going to get x plus 7, x minus 2. And then setting each factor equal to 0, I get x plus 7 equals 0, x minus 2 equals 0. And so I get x to be negative 7 and x to be 2. And remember, I did raise both sides to an even power, so I've got to check for extraneous solutions. So it could be that some of those solutions here are false. So I need to check. I know that those are solutions to this quadratic because I can substitute those in and see that the either this quadratic or this quadratic, and see that the left side will equal the right side. But are they solutions to the original? Because in the process I did raise both sides to even power. So if I check x equal negative 7 first and go back to the original, I get square root of 15 minus 3x equal x plus 1. And so when I substitute negative 7, I get the square root of 15 minus 3 times negative 7. And we see that's equal to negative 7 plus 1. So negative 3 times negative 7 is 21. So I get 15 plus 21. And I want to see if that's equal to negative 6. Well, 15 plus 21 is 36. But the square root of 36 is 6, and 6 does not equal negative 6. So x equal negative 7 is not a solution to the original. So we're going to call that an extraneous solution. All right, now let's check x equal 2. So when I do x equal 2, when I check x equal 2, go back to the original, which is this. I get square root of 15 minus 3x equal x plus 1. So in place of x, I'll substitute 2. So I get 15 minus 3 times 2 equal 2 plus 1. So I want to see those two sides are equal. 3 minus 2 is 6, so this becomes 15 minus 6. And this is 3. Well, 15 minus 6 is 9. And the question is the square root of 9, which is 3, equal to 3. And the answer is yes. So x equal 2 is the only solution. So your answer, you're going to say the solution is x equal 2. All right, so that's number 4. All right, number 5. So number 5, we have this. So we have y minus 6 equal the square root of y minus 6. And so again, we're going to square both sides. So I'm going to rewrite this over to get rid of the square root. And so when I square this side, I get y squared minus 12y plus 36 equal, and on this side, the square and the square don't do each other, so I get y minus 6. Now notice I had this quadratic, so let's bring everything to one side. So I'm going to subtract y from both sides. So I get y squared minus 13y plus 36 equal negative 6. Adding 6 to both sides, I get y squared minus 13y plus 42 equal 0. All right, and so now factoring, just like we did all the other problems, we get y minus, let's see, that's going to be 6 and 7, I think. Yep, 6 and 7. So y minus 7, y minus 6, setting each one equal to 0. I get y is equal to 7 here and y equals 6. Okay, now remember we raise both sides to an even power, so I've got to check, and I have to see that you check for extraneous solutions. So many of you don't. So you have to check this. Check for extraneous solutions. Okay, remember that's part of the process. All right, and don't say you just looked at it and said it was correct. Remember, it's the direction said show all required work. All right, so we have y equals 7. So let's go back to the original. We have y minus 6 equal to the square root of y minus 6. And so in place of y, I'm going to substitute 7. So we get 7 minus 6. I'm going to see if that's going to equal the square root of 7 minus 6. Well, 7 minus 6 is 1. And the 7 minus 6 here is 1. And so this becomes the square root of 1. And the square root of 1 is 1. And those do equal. So 7 is a solution. Then we do the same thing with y equals 6. We check. So I have y minus 6 equal the square root of y minus 6. So in place of y, I substitute 6. So 6 minus 6 equal the square root of 6 minus 6. Well, 6 minus 6 is 0. 6 minus 6 here is 0. So the radicand 0. So this becomes the square root of 0, and the square root of 0 is 0, and those are equal. So y equals 6 is a solution. So both of them work. All right. Now, it's very important that you all understand that in this process, I showed that I check for extraneous solutions. All right, and so that's part of the process. That's part of the process you have to deal with. You can't just solve. And even if you say you cross this out, I need to see that you've done this. I need to see this process. Remember, it's a worksheet. You have time to do this. You have time to show your work. So it does say show all required work to receive all points. All right, so that is the key to topic 24, radicals extra